Namaskar. This is Dr. Ravindra Khewal, Additional Professor of Environment Health, Department of Community Medicine and School of Public Health, PGI, Chandigarh. Today we are going to discuss about air quality, and I'm really thankful to Ministry of Health and Family Welfare for selecting PGMER as Center of Excellence on Air Pollution and Related Diseases. We are very thankful to NCDC for taking us along and making partner in this training program. The training program will focus on the introduction of air pollutant, how we are exposed to air pollutant, what are their health impact, and how through various policies we can benefit it. So in broad sense, we can say that there are mixture of pollutant which originate by burning of fossil fuel, wildfire, and that adversely affect our health. It can be a direct impact or indirect impact. So elevated concentration of either these fine particles or ozone, they lead to significant deaths and disease. Further, the climatic variability can be influenced by air quality, resulting in adverse health consequences. Further, it includes like aeroallergen, like pollen. I will explain this during the session. Further, when we talk about how we can minimize this, there are several policies and other, but the key is that we need to reduce where they originate if we want to reduce the burden of these avoidable premature deaths and disease. So the importance, if I talk about, you know that there was a report from Lancet which said that 9 million deaths worldwide could be linked with the environmental pollutant, means 1 in 6 deaths. And that is because of the environmental causes. I will explain this further. You can see that these deaths in total are more than if we add tobacco smoke, AIDS, malaria, alcohol, malnutrition, road accidents. So this shows the significance of the air pollution reduction and why we made this correlation. This is how the report also highlighted that out of other pollutant like water, occupational, soil, chemical, or metals, the air pollution take roughly 7 million deaths globally. So this is through based on either Institute of Health metric estimate or WHO. So you can see that air pollution is becoming a major cause of death and disease. And where it impact most? Here in this picture, you can see that it is the Southeast Asia, basically where the India also fall. So the poorest of the poor nation are being affected by the air pollution, and we need to come together to minimize its environmental and human health effect. How we define air pollution? Means basically air pollution is nothing. Nature has, means air has some substance in it. When they increase more than their natural abundance, that is the air pollution. So in air, there has been particles, but when they are more than the natural abundance, we can in broad sense define. But if we want to go in a technical term, we can say the presence of one or more contaminant like dust, fume, mist, odor, smoke in outdoor atmosphere, and that is injurious to human, plant, or animal life or cause damage to the property is known as air pollutant. They can be outdoor and indoor pollutant. Basically, you know that we use automobiles, and when they go to the ambient environment or air, they are known as ambient air pollutant. Like particulate matter, tropospheric ozone, nitrogen dioxide or sulfur dioxide. And indoor air pollutant, basically they are adverse ambient air condition inside the houses, school, place of work, and they are like furniture or many other items which can cause this pollution. We also need to understand that there is an emerging term known as household air pollution, which is related to the solid biomass fuel burning. Means we use cow dung cake, solid biomass fuel, and that is known as household air pollution. So now I will start with the first one, introduction to air pollutant and their characteristics. So we know that air pollution could be described in two categories. Primary pollutant means they are directly emitted to the atmosphere by the sources, like fossil fuel combustion from power plant, vehicle engine and industrial process, combustion of biomass for agriculture or land clearing purposes. Many natural processes such as wind-blown dust, which is a natural phenomena whenever there is a high wind speed that take out the loose soil, volcanic activity and biological respiration. At the same time, we talk about the secondary air pollutant, which means that they are formed within the atmosphere when the primary pollutant react with sunlight, oxygen, water, and other chemical present in the air. So basically these primary pollutant, and then you have sun, basically UV radiation, then you have oxygen, means reactive substance, and the water. All these things work and they form the secondary pollutant. Here you can see that how these oxide of nitrogen, they are converted into peroxyl nitrate, which is a secondary pollutant. So what are the major air pollutant? Carbon monoxide. We have seen this pollutant whenever somebody make use of coal stove and they sleep, some next day they are reported to be died because of this carbon monoxide poisoning, because it has high affinity with the blood. Nitrogen dioxide, lead, it used to be added in the fuel, but nowadays it is restricted, but the traces are still there, and which are emitted to the environment through the various cycle. Then sulfur dioxide, particulate matter, either PM 2.5 or PM 10, then ozone. So there are strong evidence for causal relationship between air pollution and premature death, and this has been proved using the time series studies of acute effect. Further, the evidence were also strengthened through cohort or cross-section studies of chronic effect. Talking about carbon monoxide, as I just highlighted, it is produced by the incomplete combustion, inhibit the capacity of blood to carry oxygen to the organ and tissue, because it has 4 times higher affinity than the, you can say, iron. So people with chronic heart disease may experience chest pain when CO level are high, and at very high level, it impair vision. You can say it also lead to learning, distract learning ability, and can be fatal. I hope you have seen a study from PGMER where we are showing that use of combustion material like in household, basically solid biomass fuel or cow dung, could be lead to lower IQ, means cognitive impact of 4 IQ will be less those who are using this kind of fuel. So this shows that it is really deteriorating our health and associated impacts. Now talking about nitrogen dioxide, produced from high temperature combustion, affect lung function in person with asthma, contribute to acid rain, secondary particle formation, as you saw the peroxyl nitrate formation. It is a precursor of ground level ozone. We need to understand that when in Delhi, we introduced the CNG engine, which has higher temperature, burning temperature, that also lead to these kind of emission. And when other pollutant goes down, this pollutant increased where these clean fuel were introduced. Sulfur dioxide, it is emitted again from combustion containing sulfur containing coal, oil, or from metal smelting operations. So where you see large steel industries, these emissions are very common. And but when we introduce the scrubber, means we dissolve this sulfur to sulfate and reduce from the you can say emission exhaust. So these technology work very well. But before that, it contributed to the acid rain and formation of PM 2.5 through atmospheric reaction. Again, it is also associated with the reversible declining lung function of the people with asthma and exacerbate respiratory symptoms in the sensitive individual. Because you know that sulfur dioxide, water, you can make sulfuric acid. Then particulate matter, PM10 or PM 2.5. They can be of primary or secondary origin because they are fine particle when there is an exhaust which emit. So they are primary, and then through these nuclei mode, they form the secondary pollutant. They are produced by combustion, atmospheric reaction, and mechanical processes. They are associated with wide range of human health impact, including premature death, because they are easy to capture and monitor. That is why these pollutants are, you can say, referred as standard pollutant, and they are the most studied pollutant. And then higher temperature may favor the secondary formation of these particles. Some particle type contribute to climate warming and other to cooling. So their net impact is still debatable, but if they, depending on the black carbon or the brown carbon, or the nature of their absorbing property, basically they contribute to either warming or cooling. Here you can see the various particle size and we see that from the term is used 1 micrometer, like 1 micrometer to 1000 is fly ash, then pollen you can say 10 to 100. So the smaller the particle, the higher the impact, we know this. So various sources are contributing, and as you can see that tobacco smoke mainly emit very fine particle. That is why the smoking kills has been established. But we need to understand that smoking is also equivalent to air pollutant, and that is why the air pollution also kill. This concept need to be highlighted. Here I am trying to show the relationship between the mass and the number concentration. You know, when we talk about PM10 or 2.5, we need to understand it is a hypothetical term because you will not see the particle of same size. Basically, what we say, having the same, it is a hypothetical term, having the, or considering that particle having the unit mass and same settling velocity. And based on that, actually, we define this PM 2.5. So what we know that if the mass is higher, the number will be less. So initially in this image, you can see as these fine particles, they are really, when they are small, they have large in number. So this is the relationship. And here you can also see the nuclei mode, which basically are emitted from the volatile precursor and they form this secondary pollutant. Then we have ultrafine particles, then accumulation mode, yani ki up to PM10. And then we have larger particle we term as coarse mode. So now another pollutant is ozone. It is one of the major air pollutant, and you know that it is a good ozone and bad ozone is also there. If it is at the ground level, it is a bad ozone. And if it is at higher in the stratosphere, it means it is a good ozone. So it is formed by the reaction of atmospheric primary pollutant NOx and VOCs in the presence of sunlight and water, and higher temperature favor ozone formation. And ozone is also a greenhouse gas, and it is a strong oxidant that damages cells lining respiratory system, resulting in a variety of adverse health outcomes, including lung function, decrease, asthma attack, or premature death. So here you can see how this ground level ozone is formed. So we can see that we have NOx and these VOC, and then we have sunlight, and then we have also the vegetation source which are contributing to VOCs. All these interaction take place and they form basically O2, and then this activated ozone oxygen particle, and then they interact and form this O3. So here you can see that how the daily pattern changes, and this was also highlighted that early morning as the vehicular emission start increasing, the sun also rises and there is a moisture in the air and temperature increases, the ozone formation increases. As the day decreases, means the night, the ozone level goes down. So this all shows how various air pollutant. Now we will talk about effect of air pollutant. First thing is that we have seen aesthetic problem. It could also impact our vegetation and plant, and even the malnutrition could also be linked in future if we are not able to control the air pollution. Then livestock, as it impacts us, it also affects our animal and husbandry. So building material, climate change, human health, and we also discuss about economical cost. So look at this. As the pollutant concentration is increasing, you cannot see. So if you are a very famous touristic place like Chandigarh, and you are standing at a Sukna lake and you cannot see it, the tourist will not come. If you are in Delhi, you cannot see the Red Fort, you will not like to go outside. It could also happen in the south that you want to see a particular mountain, or you can say Taj Mahal, so you cannot really see, and then the tourist will fall. Aesthetic, basically why we talk about aesthetic, because you have seen the various landfill site and you can observe the obnoxious pollutant because of the mercaptan, hydrogen sulfide, and that smell really stink, and people don't like to go there, and it also reduces the property price near about. Then some people are really allergic, or you can say having problem with the diesel exhaust. Same in that sewage treatment plant, the hydrogen sulfide concentration around that plant is high, and the smell become really obnoxious. Now, effect on vegetation and plant. So the most direct effect of air pollution on forest occur when trees are exposed to the particulate pollutant, and they suffer damage to their foliage. So in this image, you can see the chlorosis of leaf, basically the death of the chlorophyll. Then you can see necrosis of the leaf. So it is estimated that global loss to various maize could be really significantly high just because of one or another pollutant. Now I will talk about like various pollutant and how they affect the plant, like ethylene. It lead to leaf abscission, fluorides, necrosis, nitrogen chlorosis, ozone lead to bleaching because it has oxidizing potential. Peroxyl nitrate, it causes silver leaf, sulfur dioxide, chlorosis, and smoke, again chlorosis or leaf drop, and then particulate, basically leaf spotting, where they clog these stomata opening. So we can see such kind of damages in this image, like ozone injury to soybean foliage, acute sulfur dioxide injury to raspberry, then severe ammonia injury to apple foliage, fluoride injury to palm foliage, and then cement dust coating on apple leaves and fruit. So how it impact to the livestock? Basically, first thing is that it affect because they also do the respiration process. Second, they eat all these vegetation, and if they have high deposition of these pollutant, so it can affect their health. We have seen that through various example. Means out of 3,500 sheep, 625 died because of higher concentration of arsenic, basically sulfate, from a mile, 15 mile from a copper smelting plant. Similarly, we observed this in Germany in 1955. Here in this picture, basically, I wish to highlight that air pollution, when deposited on our cultural heritage, which has been preserved for thousands of years, it also impact them. So it can be, it can affect through abrasion, deposition and removal, direct chemical attack, indirect chemical attack, and corrosion. So here you can see that darkening of lead-based painting. So ozone caused accelerated darkening, and it also caused cracking of the rubber, and also lead to fabric deterioration because sulfur dioxide attack nylon. In terms of talking on the climate, basically most of the known air pollutant, they are also the climate forcer. Basically, they contribute to the climate change. So we know that they are the strongest greenhouse compound, and they can lead to these greenhouse gas phenomena and global warming. Local weather phenomena can also be influenced, and we know that they influence the Earth radiation budget, because Earth manages 100 radiation comes and 100 goes out, and whenever this is impacted, it affects. In this image, I'm trying to show that how these overall health effects are taking place. So from human source, we are emitting these pollutant. We have primary pollutant and then secondary pollutant, and ultimately it is affecting human health, ecosystem, and also our physical environment, where the ozone protective layer is also being damaged, and increase in temperature. And you know that we are trying to have an agreement through Paris Convention that we need to restrict the global rise of the temperature to 1.5 degree, because if it is more than that, we will have drastic human health and ecological consequences. Now we come to the second part of this presentation. And let us take a small break, and I will come back to you. Now we come to the second part of this presentation, means exposure to air pollutant. So we need to understand that what are the main sources of air pollutant exposure in my country, in my region, means in my district and in my locality, and what is being done to manage these sources. We know that major air pollutant sources could be industrial, vehicular, household emission, solid biomass burning, regional emissions, crop residue burning, and how much they contribute overall to the pollution, so that accordingly we try to make the policy. And we need to also understand the role of meteorology. Like in North India, we see that in October, November, because of the crop residue burning, meteorological condition, the air pollution become very severe. Whereas in around, you can say, March and April, we also have wheat burning activity, but the pollution remain below the standards. So why? Because the meteorology play a major role. In South, we have observed that the air pollution from the industry, from the forest fire and other increases, but overall, because of the meteorological factor, it remain and it does not reach to the you can say critical level. So we know that sources could be stationary, like industrial process, power plant, fuel combustion, solid waste disposal, municipal incineration, or they can be line sources like highway vehicles, automobile vehicles, railroad, and aircraft, which is also known as mobile sources. This is an image from Haryana and Punjab region where the crop residue burning activity is taking place. These are the natural forest fire which emit large amount of, you can say, these pollutants which we just discussed. And we also need to understand that when a vehicle move, we not only have exhaust emission, there is a non-exhaust emission also. This is a study by us. My first PhD student conducted, means how this tire erosion, loss of oil, brake wear, they all contributed more emission than the exhaust emission. And a recent study by my PhD, another student, shows that in Delhi, these non-exhaust emission could dominate these non-exhaust emission could dominate the exhaust emission. So now we will also talk about a specific air pollutant like natural sea spray. Those the cities which are near the sea, they will see a bubble and bubble burst. So what will be released? Sodium and chloride. So again, it could be also bromide and sulfate. Then mineral dust like silica, aluminium, titanium, iron. Then volcano, sulfate and carbonate, and biogenic particle, means organic carbons. We have already discussed the anthropogenic sources like fuel combustion, industrial process, having trace metals, black carbon, non-industrial fugitive sources like trace metal, black carbon, and transportation sources having this black carbon, which was categorized as non-human carcinogen in 2013 by International Agency for Research on Cancer. You know that pollen, we consider sometimes natural emission as beautiful, but we need to understand that in VOC and also in particle contribution, they could be a major fraction during a particular season. We know that whenever there is a Vasant or a spring season, their concentration increase and they contribute up to 40 to 60% of the total pollution load. So whenever we are planning a city, we need to understand which plant need to be grown up in that city, or permission should be given looking at their allergic potential. And whenever we think that, oh, these are 1, 2 pollutant, this image could show you that how a complex chemistry is taking place. I just mentioned like sea salt spray. There could be also various reaction from primary to secondary, then they can be also reverse reactions. So this is how a complex particle look like. Now let me come to the exposure pathway. People are exposed to air pollution by breathing in the pollutant by either lungs or through ingestion or through skin contact or through skin absorption. We have seen that air pollution has been linked to disability adjusted life years and death. As you can see in image A and B is Delhi's and deaths. So people link it mainly with respiratory element. But here we can see that it is the ischemic heart disease, COPD, lower respiratory infection, neonatal disorder, stroke, diabetes, cataract, lung cancer. All these are the major impact, having the major health risk because of the air pollution. In this study, you can see that proportion of the population using the solid biomass fuel and population weight PM 2.5 concentration. So central India basically has the maximum load of solid biomass fuel, and at the same time the concentration is also higher over this Indo-Gangetic belt, and that is why this remains the focus of the air pollutant. We are working out on a basin approach, starting from Jammu and Kashmir to Haryana, Punjab, then Uttar Pradesh, Bihar, and up to the Kolkata, means how these pollutants affect and impact the air quality. Now, how these numbers are related to deaths per you can say 1 lakh population is shown in this image. And here you can see that the high population state, definitely they bear the major, you can say, burden of associated death and disease. So air pollution is a major risk factor which could be linked with confidence to increase death and disabilities. In this image, you are seeing that population weight annual PM 2.5 percentage, proportion of using solid biomass fuel, and the ozone concentration. And then we can also see the distribution of annual PM 2.5 concentration in the below image, population using from the SDI 2007 study. So now, how this pollutant is related to? So air pollution, number of death in million, we can say approximately 1.7. Then ambient particulate matter, around we can say 1 million death. Household air pollution, around 0.6 million death, and ambient ozone around 0.2 million deaths. So in terms of total death, you could see that air pollution lead to around 18% death, ambient particulate matter pollution around 10%, household air pollution around 7%, and ambient ozone around 2%. So this is again showing the death rate attributable to ambient particulate matter pollution, household air pollution, and ambient ozone pollutant per 1 lakh population in India from 1990 to 2000. So we can say that the number has decreased, but still we need to continue our effort, and we need to minimize these avoidable death and disease burden. Considering this, in 2019, the National Clean Air Program was launched, and the objective was that we have institutional standing, we work on knowledge and database augmentation, and improve our mitigation measure. So it will work for 2024, the first 5-year plan, having the base year as 2017, which has been in some cities 2019, where data was available. So depending on the data availability, the base year was selected. Then the target was that 20 to 30% reduction in PM10 and 2.5 level by 2024. So having the key objective means strengthening implementation of mitigation measure for prevention and control and abatement of air pollution, augment and strengthening air quality monitoring network across the country, and augment public awareness and capacity building measure. And the approach include multi-sectoral collaborative action, mainstreaming and integration into the existing policies and program of Government of India, including National Program on Climate Change and Human Health, used smart city framework to launch and kept in 43 cities, which was extended to more and more cities. So they had key interventional policy like e-mobility, power sector emission were reduced because they are the key emissions. They are known for their high emissions. Indoor reduction in indoor air pollution, including clean cooking, integrated waste management. There was a crack on transport emission. That is why we moved from BIS 4 to directly BIS 6. There was policy and there is a you can say procedure to minimize the industrial emission and including the emission from the agriculture sector, and then the clean construction and road dust management, because they also contribute significantly. I hope you are aware that there is an air quality index, and which shows that if it is green means it is good, having minimal impact. Satisfactory means may cause minor breathing discomfort to sensitive population. Moderate means 100 to 200 may cause breathing discomfort. Poor means 200 to 300 may cause breathing discomfort to people on prolonged exposure. And then very poor may cause respiratory illness to the people. And then severe. So our strategies and action plans should be based on these air quality index. And we need to prepare for the months when we see high air pollution episode in the category of very poor and severe. So what could be the health impact of PM and ozone? We will specifically discuss this. But before that, we need to understand that nature of the pollutant, concentration of the pollutant, duration of the exposure, state of the health of the receptor, and age of the receptor, all these impact. So that is why sometime when we take the emission, you can say from the India and the Europe, they are not directly linked to the same kind of health outcome. We need to understand that our population is different and we might have different response to the air pollutant. So that is why we are highlighting that we need to generate more local and regional evidence, means how air pollution affect, because the nature of the pollutant is very different. And we know that our population is mainly the younger population. So whenever there is a emission, it goes to the, from a particular source, it goes to the environment and we measure it as a concentration. Then the exposure means duration and intensity of the contact. Have you been at the red light area where those who are known as the hot spot of the emission? Because many vehicles remain on this cross road where several studies highlight that whenever there is a red light, the people are exposed to the highest load of the air pollutant. Then coming to the dose, of course, it depends on the gender, age, genetic acquisition, and but it highlight the body burden, means where it will reach and what health impact it could cause, and then we follow this based on these evidence we make the particular policies. So what are the various factors which can influence exposure? Occupation, duration, activity pattern, where do you work, proximity to road. India is the only country where people highlight that they need a house near a major road. And we have seen from the Bad Broken Reef from Netherlands that those who live near the road, they have the major health issue, starting from stroke to arthritis to many other diseases. But still we prefer to live around the road. Traffic pattern is high, you can say load vehicle like truck and other, or it is basically e-mobility, and presence of other pollution sources which can make it more toxic. So which a point I highlighted was that our source is different than developed world. Our pollutant concentration could be taken as a cocktail of pollutant. We have a young population. Maybe we have a malnutrition issue in our country. Our climate is, we see extreme weather basically, and mega cities are all around us, like in near Chandigarh, we see Delhi. So Delhi has 2 crore population, means in a particular geographic location of you can say 25 by 25 kilometer grid, and Punjab has a population of 2 crore. So look at these patch emission, and that could act as a major industry. So, as I just highlighted, the prime factor that affect human health are nature of the pollutant, concentration of the pollutant, duration of the exposure, state of the health of the receptor, and age of the receptor. In this example, I am trying to show that how this causal chain model is leading to the associated health effect. We can see that there are motor vehicle exhaust, and then these non-exhaust emission having either ultra-fine particles, polycyclic aromatic hydrocarbon, and same in the non-exhaust emission, the dust particles. So you could be exposed to the short term or long term, and it could affect your airways and immune system. So how these reaction will start? It could be lung inflammation, hyperreactivity, decreased lung function. Then you will have some symptoms associated with the decreased lung function or increased susceptibility to the infections. It could also reduce lung growth, as we have seen in some children in Delhi and in many other cities. And then it could also, you can say, induct the asthma and sensitization. So what could be the consequences? Use of medication could increase. You will be having limited activities. Emergency department visit could increase, and you may have to be hospitalized because of this. And then as an outcome, you could also be adversely affected by the air pollution. Now talking about health effect of air pollution, basically either man, woman, there is no organ or body part where air pollution does not affect or impact. Here you can see pollutant and what they are causing, like headache, anxiety, sulfur dioxide, central nervous system, particulate matter, cardiovascular disorder, liver, spleen, blood. So basically starting from these small, means you can say impact like headache and other, they also lead to low birth weight, premature birth, and impaired lung function development, possible birth defect. And a recent study by us shows how the congenital birth defect could be linked with the air pollutant. Of course, eye, ear, nose, throat irritation, and respiratory irritation, which are very common, and leading to impaired lung functions, chronic obstructive pulmonary disease, or lung cancer because of the particulate matter or these diesel exhaust and particulate polycyclic aromatic hydrocarbons. Here, I would like to see an image of a lung where you can see this black carbon or soot deposition. So, Doak and Popri, they worked on how these air pollutant affect, and we can see that these air pollutant affect starting from, you can say, hospital admission to Delhi mortality. So whatever we just discussed, they highlighted and related it with incremental value of the air pollutant. We need to be also aware of the nanoparticle, because not only the natural nanoparticle were always there, but the synthetic and you can say engineered nanoparticle, they could be a threat also, because they are being used in as a diesel additive or in various industrial processes. And once these nanoparticles attach to the toxic metals, they can reach deeper into the blood, means to the body, means they can cross the blood-brain barrier and can impact or adversely affect our health. We also know they are first non-human carcinogen as polycyclic aromatic hydrocarbons. And we use them like naphthalene ball, you can see everywhere. And there was a study in 2003 which said that this small, we think that, oh, even you eat in kilogram, it will not have a health effect, but there are emerging evidence. So we need to be carefully use this compound. And they are the major component of environmental tobacco smoke. So we can say that we need to have a discussion over these metal, you can say, related to the ill effect, or this is the number, size, shape, or we can say means how these various pollutants are affecting our. But there is no clear mechanism at this moment which affect, which explain the how these affect. So there is a one which says about metal lead to this, another says this fine particle lead to this, and we need really high clarity on this. And we need to understand about the low level of air pollutant, how they can affect. And they, as I highlighted, the new findings, we need to look at and understand that we are living in the age of shifting of pollutant. First, it was lead. So we introduced MBTE, methyl butyl tertiary ether. Then we say it is also carcinogenic. And then we had another substance. So we need to look at these emerging pollutant, and before releasing to environment, their health risks need to be better understood. Means because Europe, there is a REACH regulation which look at these emerging pollutant. And when we talk about emerging pollutant, means emerging chemical risk, emerging issues, and means there could be circuiting risk. So we don't understand how these various new product could be dangerous to our health and environment. And that is why we are seeing this unexpectedly growing or developing risk due to increased consumption of these products. We also need to examine these hidden latent risk, like when these gases which we used in our refrigeration unit, they were referred as magic compound, but later on we came to know that they lead to the deterioration of the ozone layer. So CFC's products were banned all over the world. And then we know all the story, and there was a Nobel Prize to Paul Curzon and other colleague on their discovery. So we need to understand the future risk, which are currently not existing, and new generation of chemicals and various product which are being introduced to the environment and their health risk. And in this image, I would also like to show means how various age group, either it is newborn, infant, or young child, or school-age children, or adolescent, and you can see with over a time that how they are impacting the health. So if we talk about short-term impact, the ministry document also highlight starting from eye, nose, throat irritation, flu-like symptoms, headache, pneumonia, coughing, fatigue, or rashes. And then it could also lead to allergic reaction, loss of coordination, irritation in mouth, excessive perspiration, and then humidifier, fever, influenza. So longer term impact, basically impaired lung function and respiratory function, bronchitis, lung cancer, ear infection, increased risk of heart disease, cause cancer in animal, damage to kidney and central nervous system, possibility of stomach cancer, and you can say if you are exposed in a very high concentration, means it could lead to the death. So as we highlighted, there are sufficient evidence that air pollution is a major risk factor to human health and our ecosystem, and we need to work upon. These evidence not only come from these time series analysis using economical approach, utilizing readily available data, temporal studies to avoid confounding, and they shows that air pollution follows seasonal cycles, and you know that during the monsoon the air pollution will be lowest, but it will be impacting, and then the days of the week when it will affect the most because of the increased level. Through the cohort studies, which are expensive and you can say, but provide more robust result, we have seen that we can address long-term chronic effect of air pollutant. So large population in multiple cities enrolled and followed for many years to determine morbidity or mortality experience. We need to control for societal confounder like smoking, income, genetic differences, diet and occupation. And assessment of confounder at individual level is an advantage over cross-sectional and ecological studies where you can have the matching population also. So in this image, you can see the estimated change in premature mortality with change in PM2.5 and ozone. And we will see that it impact mainly in Indian part and Chinese part. So as highlighted in the study, either WHO or Health Effect Institute, the Asian and the African continent, they are affected by most. So we need to understand these avoidable death and ecosystem losses could also, if we can minimize, it will be benefited to the economy. So we know that there are national air quality standards. They are based on either 24-hour, means higher concentration, and if it is annual, the lower concentration is allowed. Our standard are laid down by Center Pollution Control Board, and they are the authority for the implementation of these standards. WHO standards are much lower, means like 10 microgram on annual mean and 25 microgram on 25-hour for PM2.5. We need to look at our own standard, and they are based on global standard, and we need to understand that their geographic location, the meteorological pattern may vary. So we need to understand our location, the natural contribution and all other factor, and then we develop such standards. So talking about what are the key effects on air pollution by WHO means urban outdoor air pollution can be reduced by policies and investment supporting cleaner transport, energy efficient housing, power generation, industry, and better municipal waste management. That is why we are having this concept of smart cities. Rural and peri-urban area pollution sources can be reduced by decreasing outdoor emission from household coal and biomass energy system, agriculture waste incineration, forest fire, and certain agroforestry activities. So this image shows that co-benefit of avoiding premature mortality from PM2.5 and ozone. So we have large potential. Basically, if we look at to minimize the death and disease burden of air pollution. So we have covered in this module introduction to air pollutant, exposure, health impact, and benefit of air pollution reduction policies like National Clean Air Program, and you will see that it will have major impact. So what should be the learning? That the mixture of the air pollutant produced by burning of fuel and or by a natural emission like wildfire can adversely affect human health. It could be direct or indirect. Elevated concentration of particulate matter and ozone cause significant mortality. Climatic variability influences air quality, resulting in adverse health consequences. Means like there could be a pollination period could be extended. And we know that we have seen this. And then reducing the sources of air pollution would prevent avoidable premature mortality. So now all state climate change cells and all health professionals, they need to come together so that we take action and we implement our health adaptation plan at the ground level to minimize these deaths. So now I ask you one question: what action will you take in your work given what you have learned through this module? So thank you very much. This is Dr. Ravindra Khewal, Additional Professor of Environment Health, Department of Community Medicine and School of Public Health, PGI Chandigarh, and you can reach me at khewal@yahoo.com. And soon we will come back to you with your regional health risk vulnerability, including the vulnerability mapping of your zone. We can make use of satellite data. We can make use of existing air quality. You can say stations which are being placed as National Ambient Air Quality Station or continuous air quality monitoring stations. So we look forward to support you We look forward for your collaboration, and we are here to support at each and every step. Once again, I would like to thank the Ministry of Health and Family Welfare and National Center for Disease Control, including and specifically Dr. Sujit Singh, Dr. Akash Srivastava, Dr. Rameswar, and all of you for joining and giving us the opportunity to speak to you. Thank you very much. Namaskar. Bye bye. Jai Hind, Jai Bharat.